Alright guys, we got another one of these Alpine 1507s on the bench here. This one come in with some output issues. So we're going to have to take a look at this. Kind of just doing a little inspection right now. I noticed there's just a few little minor things like broken plastic pieces on some of the terminals. Nothing really crazy that's going to prevent it from working. I'm just looking for any electrical component damage like RCAs or loose terminals. I did notice that these are missing screws. They're probably stripped out. Very common on these amplifiers. What you can do is try and retap these for a larger screw, or drill them out and put another lug in there. Kind of a pain in the ass, but it's the only thing you really can do because you can't really find new parts to put in this, so you kind of have to fabricate your own. So I'm going to flip this over and show you some of the issues that the customer wrote down on this, and we'll crack this open and see if we see anything obvious or get any hints from the description. Okay, so it looks like the customer wrote down a little note here. I asked him to just write it down, some of the issues he's been having with it, so I know what to look for. And it looks like subwoofer holds up at 4 ohms. Subwoofer slowly pulls in, pops, then protection light flashes and sub returns to normal. This happens regardless of RCA input. So I think what he's saying is the speaker gets sucked in or pushed up and it just stays there, and then it thumps and then goes back down to normal, and then the amp goes into shutdown. I'm kind of thinking that it's not power supply. I'm kind of thinking this is going to be an amp section issue. Because if the speaker is being pushed up, that means there's voltage there, and that voltage is supplied from the power supply side. So I'm kind of thinking that we might have some shorted fets on the amplifier board, and or gates. Something might be just screwy in this circuit. I'm going to have to pull both boards anyway because these are notorious for blowing traces on the grounds on the bottom of the power supply board. So I'm going to have to just check all of it out to make sure. So there's no future issues. So I'm going to crack the back cover off of this and see if we see any legs off the fets exploded or anything like that. Okay, so I have the amplifier open now, and I'm just taking a look around the circuit board to see if I find anything obvious that might be blown here. I don't see anything, but I do see this is the speaker connector. I don't know if this happened in shipping or this is an old problem, but the side plastic piece to the one of the speaker terminals is cracked here, and it's kind of inside there's a piece floating here that was on the back side. It's not going to really hurt the operation of the amplifier, but it's just one of those things that may have been done during shipping, or the guy that owns it might already know about that. So I'm not going to worry about that because that's not what we're here to repair. So let's take a look around for problems on the fets. I kind of think that it's got something to do with the amplifier board. I think there might either be a shorted fet, but I'm not entirely sure. So I'm on the one channel of the amplifier, and if you notice that the stock fets have green color on them, and on the other side over here they're yellow. So that's how you know that the fets that are in this amplifier are the originals, because they colored them at the factory. And what they're telling you here is that one color versus the other color are two different parts. One is an IRF 540N and the other one is an IRF 9540N. So you have a P and an N fet on each side. There's 4 on this side, and there's going to be 4 on the other side of the channel, and same for the other side, the other channel. It's a 2-channel amp, so you have 4 N parts and 4 P parts for one channel, and same for the opposing channel. So I'm just going to check from, this is the gate, This is the drain, this is the source. I'm just going to be checking the drain to source and look for shorts. I have it on my ohms scale right now. And I'm just going along and checking all the fets. Now, I pretty much have already determined before I started this recording that all the fets in this amplifier seem to be okay. They're not shorted from gate to drain. Typically when these fets die, they die in a shorted condition most of the time. They usually don't open up. So if you have a short, it'll be evident, it'll be 0 ohms or close to. But if they're open in the, somewhere around the kilo ohm range or greater, you can probably assume that the FET might be okay. I mean, without pulling it out and testing it properly, you're not really going to know 100% for sure, but just going around like this and testing the gate to drain, drain to source, you can check for that short, because that's mostly where the power is being used as the drain to source. The gate is actually what turns off and on the FET. So the drain to source is the actual so-called switch between each other and carrying the current. So if these are shorted, this is probably where it's going to show first. And if you have a short from gate drain or source to gate, and that's pretty evil, because the gate should not be shorted to any one of these. You may show something in the kilo ohm range, and that's normal because you're going to have other components in the circuit that's going to influence that reading. So that's going to be kind of normal, and you can compare them across other parts in the circuit. So if you measure from gate to drain here, and you get like, let's say for instance, I get 22 ohms here, and then if I go over here and measure that, I get 22 ohms. So I can assume that the gate to drain is going to be the same across all these FETs and is going to be good. So you can kind of compare across each other like that. But if you have any shorts, that is without a doubt an issue. So like I said, I pretty much have already gone over this whole amp board and tested all the FETs. These two transistors are for, I think one of them is for biasing, and I forget what the other one was for. They all look good. There are no shorts, let's just say good. So, yeah, I'm not entirely sure what's wrong with this thing yet. I may have counted my chickens before the eggs have hatched. So, thinking that it may not be the power supply, because it most certainly could be. But I've already checked the power supply board FETs in the same manner I've checked the amplifier FETs, and the same procedure is checking the FETs, and those all show good. So I think the next step is to actually give this thing a run up and see what it's doing. Maybe I'm not understanding the problem, or it's not being relayed to me exactly the same as the person thought is happening. So I think I'm going to try that. The only thing I haven't checked yet are these Noble resistors. We can most certainly have one of these open, and these are those dual resistor packs in these. I think they're 5 watt ceramic. So we could definitely have one of those open, causing this issue. They're 0.1 ohm, 5 watts, dual resistors. We could have a crack in one of these, or one could be open somewhere across these. So we don't know about that yet. So without pulling the boards out, we're guessing. What I like to do is just see if I can do this here. Let's get this cam off. What I want to do is give this thing a run up, see if it turns on. I'm going to limit this thing to about 2 amps, so it's not going to run away, it's not going to start exploding FETs if there's something seriously wrong. But I feel comfortable that the FETs are going to be safe, because I've already checked them and there's no shorted condition on these FETs. So I'm going to find out what's going on here. let's plug it in, and the fan turned on. Power supply started up somewhat. Okay, I'm looking at my current meter here. Let's see if I can get this on tape here, and I'll cut this into the video. But basically, what we have going on with the power supply is it's fluctuating. It seems like it's trying to turn on and it's shutting down. It's drawing about, oh, let's get this shot in here. It's drawing about 190 milliamps, and then it tries to turn on, and then it shuts down. And then it tries to turn on and then shut down. There it goes, right there. So I kind of think that what the person said to me is maybe true. He said that he had the speaker going up and then coming down and settling out. That's showing me that is DC coming out of the amplifier, and possibly the protection circuit shutting this amplifier down. So we can still definitely have a problem with this amplifier board. What I like to do here is separate the amplifier from the power supply and see if the power supply will comfortably turn on and supply the plus and minus 49 volt rails, and move on from there. If the power supply is good, then we won't have to do much with that. I'll still have to pull the board up because there are a few known problems with these circuit boards in certain spots that tend to have issues, but don't cause anything that like this for an issue, but are good preventative things to take care of. So gonna have to check for that. And the funny thing is here, this circuit board is definitely a different color. Usually they're brownish. This is kind of like a reddish color. I don't know if this is an early or a later model or something, but this is definitely a first for me to see one of these amplifier boards that have this kind of reddish hue to the circuit board, or it's yeah, I've just never seen that before on these amplifiers. So I think what I'm going to have to do here is check these speaker terminals with the scope, and when it's trying to turn on, see if we're getting some kind of DC condition after we test the power supply. Make sure the power supply is just not shutting down under its own problem. So I'm going to disconnect this jumper from the amplifier to the power supply and these two cables here and pull them up, and we're going to run up the just the power supply and see if she turns on by herself. Alright, I am going to test the power supply. I already disconnected the power supply, this cable here that jumps over to the amplifier board, and these two other cables. And we're going to test the positive and negative 49 volt rails and to see if we get them from the power supply without it shutting down. And if it does, if we do get those voltages and the power supply doesn't shut down, we can almost believe that the power supply is okay and we're dealing with something in the amp. So let's turn this on. And if you're looking at the connector from the right side, the second pin in is ground, and the outer outer pins are the voltage pins. All right, we got minus 49 volts there, and it's stable. And this should be the positive 49 volts is the first pin. All right, so power supply has turned on, and it is stable right now. Obviously no load hooked up, and we're running about 300 milliamps of current just to turn on the supply. All right, so I think the next step is going to be plug this back onto the board and scope the outputs and see if one of these outputs here, scope the channels, see if this channel or this channel is going into DC before it's shutting down. We might be able to catch it on the scope, see if that flat line goes up and then comes down. What it should do is you shouldn't have anything on there. You shouldn't have any DC on here. So if we see one channel going up or down, we can isolate this whole amplifier down to 1/4. So it's going to be either this side or this side. I've already pretty much think that the power supply is okay now. So yeah, that's going to be the next step. Alright, so I have the scope hooked up. I have the yellow channel and the violet channel hooked up to the amplifier. The yellow channel is this channel and the violet channel is this channel. So if we see any DC fluctuation in any of these channels, we know which channel to go after. So let's just do a quick turn on and see which one moves. Whoa, okay. It looked like the yellow channel dipped down, and that's probably what's causing that DC protection to trip out, is something in this quadrant of the amplifier. So we know it's on this channel now. Now we've isolated the entire amplifier. We've verified that this is okay, and we verified that this might be okay, and this is putting out the DC that's probably shutting down the amplifier. So we're going to start searching in this area for an issue. It's either going to be a leaky FET, preamp circuit, pre-drivers, or these nobles may be open, or something similar like that, or it could be biasing. I doubt it's biasing, because that's not a typical symptom of bias issues. So yeah, so I'm going to pull the amplifier section up and we're going to start looking at components. Alright, so I have flipped the board over and I'm just inspecting some of the connections on the back of the circuit board here. And I come across a few concerning things that I need to address, and it may or may not be the issue here. I'm kind of hoping it is, because it seems pretty severe enough that it would cause some unknown conditions like this. Let's go to the microscope here and you can kind of see what I'm talking about. See if I can get this in focus a bit here. On the pre-drivers, which get very warm, I think the solder connections on the board have been compromised. Let's see if I can actually find these again with okay, here and here. Put my finger so I can see it. Alright, good. Alright, so I'm going to zoom in now and you can see what I see. These are the part of the channel drivers, and you can start to see a little bit of cracks on those solder joints. There's cracks on a lot of these solder joints, but the more concerning thing is I don't know if you can see that, but it's cracked enough where it's really not connected all that well. Let's see if we can zoom in even more here. Wait for this thing to stop shaking. All three of these are cracked and moving. On this one here, we have a very similar thing going on. It may even be a little bit worse, especially that one right there. So this could be causing the weird DC condition. I'm pretty sure it's not helping. So I'm going to have to go over this whole circuit board here where all the heat builds up from the pre-drivers, and get these pretty much all back to good connections here before I can proceed, because this may or may not be the issue. I'm leaning towards 80% that this is probably the issue, because it looked like those are pretty broken all the way around, and without those transistors really connected in circuit, it's not going to do its job. So I'm going to touch up those solder joints and see what happens. Okay, so I did those connections up, resoldered them, and let's see what we're drawing for current now. Let's turn it on, see if it turns on. And whoa, okay, yeah, 4 amps. So now she's turning on, but she's still not happy, but it definitely made a difference repairing those connections. So I think we found the first part of the problem. we're going to have to go through all these pre-drivers here on both sides here and find out if there's any issues going on. I suspect there's going to be a short somewhere. This capacitor here looks a little bit kind of bloated a bit. I don't know if it's just been over heat shrunk for the specifications of the cap. There's usually a little sleeve. And it's supposed to look like this, curled over. So this either got hot or it was over shrunk at the factory. So we're going to pull that capacitor out to make sure she's okay. The other side here appears to be normal looking. So I don't know, maybe this something's gotten hot in this circuit on this side. Who knows? This is the point where we know that the fets are probably okay, and if we can't get this thing to fully turn on, we're never going to be able to see the bias currents or the idle current adjustments for these fets, because we're still dragging down the 50 volt supply somehow, somewhere. So there's going to be a semiconductor here or capacitor shorted out somewhere. I believe I've gotten all the bad solder joints, so yeah, so it's probably going to be in the pre-drive section. Not 100% sure yet. You know, like everything else, it's just one thing leads to another, and you just kind of narrow it down until you find the issue. Alright, so I've pretty much probed the components in the circuit that I suspected had a shorted component in the pre-drive section. It appears that everything is okay. I probed all the most common components that would fail. So I'm moving on to the 15 volt section of this amplifier, because there is another supply that gets converted from 49 volts plus and minus down to 15 volts plus and minus. And these two transistors here are part of that circuit, and there are two Zener diodes. One is hidden underneath this capacitor here. So we're going to check out those diodes and the transistors. That capacitor here, that I took it out and ESR'd it, everything was okay. So it was just a heat shrink on the labeling of the capacitor. So that is okay. So now we're just going to go after these transistors here and see if anything is evil going on the 15 volt supply that's drawing the current. So I'm going to put this, make sure this is on diode check, and that one looks good. That one looks good. Reverse it. All right. Ooh, I do not like that number. Yeah, that's no good there. This could be either this component. I've been fooled by this before. It's either can be this component or this diode here, this Zener 15 volt Zener diode. Yeah, that's dead shorted. So that Zener's cooked. Let's check this other Zener that's hiding underneath here. See if that's any good. Yeah, that's good. I'm gonna check the other direction. Yep, she's good. So we got a cooked Zener here. ZD608 and possibly Q19, Q619. We'll pull the Zener up and we'll take a look. But yeah, it's not looking too good for that. It's either the Zener took one or the other. It's either the Zener took this part out or this part took the Zener out. I'm not sure. Hopefully that those bad connections cause enough of havoc to overcurrent this side of the circuit and just wiped it out. And that's all that we're dealing with now. So we're going to pull that Zener up, and then I'll measure the transistor, and if it looks good, I'll just whack in a new Zener, and if not, we're going to whack in a new transistor as well. Alright, so I've taken that Zener out, and it's just right here. I'm going to measure across it and see what it says. Oh yeah, she's junk. Alright, so let's hope that that transistor didn't get taken as well. Unfortunately it did. So that needs to be changed out. Yeah, so I think we'll replace that Zener and that transistor, and I'm hoping that that takes care of it. Like I said, there's nothing else evil going on here in this circuit that I can tell. I think that maybe in the pre-drive, something with those bad connections caused this thing to possibly short. I guess we'll find out once we boot this thing back up with new parts in it. We'll definitely be current limiting this thing down to probably about 2 amps to make sure everything is okay. We're not going to unleash this girl until we're 100% sure that she's not going to run away and start popping stuff. So, alright, I'll have to find a replacement for that in my parts bin. Alright, so I've replaced that transistor in the 15-volt circuit in the Zener. And we're going to give this a power up, and we're going to cross our fingers and hope that this thing doesn't run away. This thing typically idles around a volt, volt and a half, about 1.5 amps. It shoots up to about 2 or 3 amps, and then it settles back down to usually about 1.5 amps. So if the thing starts to go, if it's a little high or low, we still have to set the idle current, so we haven't done that yet if this works. So let's turn it on and let's see what she does. I'm going to plug it in right now. Come on, go down. Alright. Alright, so the idle current's right where it should be. About 1.5 amps. And she's on and she's not turning off. And the fan's running. So, yeah, I think at this point, I'll hook the generator up to it and see if we get any output. Actually, before I do that, I'm going to set the idle currents for the fets and make sure that they haven't drifted off over time. And, you know, if hopefully we'll have an output. Alright, so I'm about to do the idle adjustment on this amplifier. Let's see. The spec says plus or minus 0.6 volts. We're targeting plus or minus 0.6 millivolts, and we're targeting 1 millivolts. So we have 1 millivolt plus or minus 0.6. Right now we're at 0.3 millivolts, and that's on the hairy edge of being a little low, so I'm going to tweak this thing up a little bit, and we'll get it close to 1 so it has a little bit more room to play around in. And that potentiometer is right there. Like I said, these 2 posts where those things connect to do the adjustment, be very careful. They're so close to the fets. If those things pop off and touch a fet, we're in for some more problems. So you got to get in there very gingerly with the golden screwdriver and slightly tweak this and see how fast she runs off. We're going to get this close to 1 as possible and back off a little bit. Kind of really touch it, and I'll leave it right there. That's pretty good. So I have to do the same thing to the opposing channel on the other side, and this thing should be good to throw a signal through it. Alright, so I have the amplifier under load right now. I have it hooked up to my load resistors on this heatsink. They're not fastened down to the heatsink, but I haven't got to that, but they're getting nice and toasty and warm. We're drawing a good load on this thing right now. She's nice and warm on the amplifier side, nice and cool on the power supply side, because it's got a fan on the power supply side. They really didn't do much for cooling other than the heatsink on the amplifier side, so this has always been a kind of a sore spot. But she's working. I got 2 channels on the scope here. It hasn't moved. They've been pretty solid. Well, they've been rock solid. They haven't collapsed or done anything evil. No flat lines, no DC or anything, so I think we're good there. We have all our green lights here. The music light flashing. That means music. And the protection light's green, not red. Power light's green, not red. We're good to go here. So Alright, so if you guys like this video, hit the thumbs up button. If you guys hate it, hit the thumbs down. If you liked it, hit the thumbs up and the subscribe button. If you're not a subscriber, come back and you'll see some more repairs from me. Definitely will have some more coming soon. And that's about it. So another Alpine 1507, Mrv-1507, resurrected from the dead. Well, I love these amplifiers. These things, oh, they're really nice when they work. You just can't run them lower than 4 ohms, guys. That's all I recommend with these things, and they'll last you a long time. Sometimes it happens like with this video, and you know, you get some odd problems, and it seems like it was pretty well taken care of otherwise. So I think this was just a case of bad soldering from the factory, or just because I did find some solder connections that were half soldered, and I just don't think this actually got the amplifier board, at least didn't get the soldering 100% right from the factory. So this could have been caused that issue where we had the transistors were shorted out the 15-volt supplies side, and I'm just rambling on here. So that's it. I'm done. All right, guys. Have a good night.